Hello dear students, this is grade 11 mathematics lesson on unit 9, further on trigonometric functions. This chapter is designed for natural science students only. So today we are going to see this one, the graph of f of x is equal to a sine kx plus p plus some constant c, and we try to solve some trigonometric equations. So after revising this, you are expected to draw the graph of f of x equals to a sine kx plus p plus c form and solve some trigonometric equations. So let's continue. Graph of f of x is equals to a sine kx plus p plus c. To draw the graph of f of x is equal to a sine kx plus b plus c, rewrite the function first in this form. Rewrite the function, this function f of x is equal to a sine kx plus b plus c in this form. A sine, factor k here. When you factor k, you will have x plus b over k plus c. We need to rewrite the function in this form. And then we apply shifting method to draw this graph. So the graph of f of x equals to a sine k into x plus b over k plus c can be obtained from the graph of this one, from f of x is equals to a sine kx, by shifting c units from this graph upward or downward depending on the sign c. If c is positive, you shift the graph this c units up, or if c is negative, you shift this graph downward. Not only this one, in addition to that, you shift b over k units for this part. You shift b over k units in the horizontal direction. If b over k is negative, you shift to the right. If b over k is positive, you shift this to the left. Therefore, you shift the graph b over k units in the horizontal direction. If b over k is positive, in that case you shift to the left. If b over k less than 0, you shift to the right. So simply, you can draw the graph of this expression from f of x is equal to a sine kx. How? By shifting. First, you shift c unit down or up depending on the sign, and then you shift b over k unit left or right depending on sign of b over k. If it's negative, you shift to the right. Positive, shift to the left. So let's see example for this. Before example, the period of f of x equal to a sine k into x plus b over k plus c will be similar to this one. The period of a sine kx and a sine k into x plus b over k plus c is this 2 pi over k. Its period is 2 pi over k. Simply, you divide 2 pi by this coefficient, And the range of a sine k into x plus b over k plus c is range minus amplitude plus, since you shift c units up, so you add c on the amplitude, okay, minus a plus c, comma, the other part positive absolute value of a plus c. Therefore, the range of fx a sine k into x plus b over k plus c is on this interval. It is negative absolute value of the amplitude plus c, comma, amplitude plus c. So let's see example for this. Okay, example. Draw the graph of f of x equals to 3 sine 2x minus pi over 3 minus 2. So we are asked to draw the graph of this first. Let's determine the amplitude and the period of this expression. First, what you do is we need to write this expression in other form. We have this y is equal to 3 sine 2x minus pi over 3 minus 2, and factor these two, the coefficient of x. So you'll have this one, 3 sine, when you take 2 outside, you have x here, minus, you divide this by 2, you get pi over 6 minus 2. So this is it. From this, you can see that the amplitude of this function is this, it is 3, its amplitude is 3. And its period, 2 pi over k. 2 pi, k is this coefficient, therefore the period is this, 2 pi over k is 2, 2 pi over 2 is pi. And its range is this, c is negative 2 here, so you have this one, negative 3 plus c, it is minus 2, comma, positive 3 plus c is minus 2. So the range of this function varies from negative 5 up to 1. So now let's try to draw the graph of this expression. We have this one. So to draw the graph, simply apply shifting rule. First, draw the graph of y is equal to 3 sine 2x. So the graph of sine 3 sine 2x, its amplitude is 3, and you will have this graph for f of x is equals to 3 sine 2x, and then you shift this graph 2 units down, and then pi over 6 units to the right. We have this one. We shift the graph by pi over 6 units to the right and 2 units down. So this peak move down to, just you shift 3 and subtract 2, you will have the peak will move down by 2 units. So here also this peak moves down from minus 3 to minus 5, 2 units, minus 5. Not only this one, we need to shift horizontally by pi over 6 unit. Therefore, this part is moved to this part by pi over 6 units. So shifting this peak horizontally by pi over 6 units, you will have this one and so on. Therefore, by shifting, you will have the graph of f of x is equals to 3 sine 2x minus pi over 3 minus 2, like this. So this is it. Now let's continue to the next part. Okay, the next part is general solution of trigonometric equations. To find, if you draw the graph of y is equals to sine x and the line y is equals to half on same coordinate system, you will have this one, the graph of sine x and the line y is equals to 1 over 2. As you can see, this graph of sine x and y is equals to 1 over 2 cross infinitely many points. Here, their intersection, and so on. Since sine function is periodic, you will have so many answers. Therefore, this means that sine x is equals to 1 over 2 has so many solutions. One solution here, another, and so on, since periodic. So for a certain interval from 0 to 2 pi, from 0 to 2 pi are these 2 points. These points are pi over 6 and 5 pi over 6. So to find the technique of finding solution, we'll proceed. To find the general solution, we have a technique. So we'll proceed to that. These two are particular solutions for sine x equals to 1 over 2 on this interval from 0 to 2 pi. But the general solution has infinitely many solutions, so we'll see how to determine the general solution for this expression. Let's continue. So general solutions, look, if we have tan x equals to t, where t is any real number, as you know, the period of tangent function is pi. It repeats itself after every pi. And if x1 is a particular solution on this range from negative pi over to pi over 2. Okay, let's see the graph of this tangent function from negative pi over 2 up to pi over 2. The graph has this form. This will repeat this asymptote. Therefore, on this range, if x1 is a particular solution, then the general solution of this tan x will be this x1 plus n pi, because this tangent function repeats itself after every pi. So if we have one solution here, we have also another solution on the next period, and so on. So general solution of this tan x equals to t is given by x1 plus n pi, x1 plus n pi. Now for cos x is equals to b, if b is less than or equal to 1, the period, you know, the period of cosine function it is 2 pi. And if x1 is a particular solution in this range from negative pi up to pi, then negative x1 is also another particular solution on same range, because you know that cosine is even function. So cos negative x and cos x are the same. So if x1 is a solution for cosine, minus x1 is also a solution. So here, if x1 is a particular solution on this interval from negative pi up to pi, minus x1 is a particular solution. So to find this general solution, you add a multiple of period to find the general solution. Therefore, the general solution will be x1 plus a multiple of its period 2n pi and minus x1 plus 2n pi. So for sine function, if b is 0, assume sine x equals to b for absolute value of b is less than or equal to 1. If b is 0, the solution set is n pi. The solution set for sine function, or sine function will be 0 for a multiple of pi. And if b is equal to 1, then the solution for sine x equals to 1 will be this pi over 2 plus 2n pi. You can see this graphically, by the way. If you see this one, we have 0 here, pi over 2, pi, 3 pi over 2, 2 pi. As you can see from this graph, sine function will be 0 at 0, pi, 2 pi, at n pi. And if b is equals to 1, means the sine function will have value 1 at pi over 2. Not only at pi over 2, if you have this one, since the sine function period is 2 pi, you can add 2 pi. So the general solution for this will be pi over 2 plus a multiple of 2 pi, that's 2n pi. For b is negative 1, means this part, negative 1. And we need to find the particular solution on the interval minus pi over 12 to pi over 2. So from 0 to 2 pi, I can take this. So minus pi over 2, we have minus pi over 2 here. For this case, no problem. For f of x or sine x equals to minus 1, sine x will be minus 1 at minus pi over 2. You can see this one. For x minus pi over 2, the value of sine function is minus 1. We have one particular solution, minus pi over 2. So you can add a multiple of 2 pi to find its general solution. So the general solution will be minus pi over 2 plus 2n pi. But for this interval, sine x equal to b will have two particular solutions on this part from 0 to 2 pi. This is 1 and minus 1. Between this interval, if you cross a horizontal line, that horizontal line touches the graph at 2 points. You will have two particular solutions, or the interval 0 to 2 pi if b is between 0 and 1. Absolute value of b is between 0 and 1. So in this case, you have two particular solutions. So one particular x1 and x2 on this interval. So the general solution will be the particular solutions plus a multiple of 2 pi. So therefore, x1 plus 2n pi and x2 plus 2n pi will be the general solution for such expression sine x equals to b. So let's see example for this explanation. Now here we are asked to determine for these expressions. First, let's start from a. Sine x is equal to negative 1 over 2. Sine x is equals to negative 1 over 2. We need first to find two particular solutions on the interval 0 to 2 pi. So sine function be negative on fourth quadrant and third quadrant. Therefore, half is the reference angle will be, it is sine 30 gives you half. So the corresponding value of 30 on third and fourth quadrant angle must be calculated or determined. Therefore, for third quadrant angle, we have this part means 30 degree means our angle is this one. Therefore, this angle means it is 30 plus 180, 210. So when you convert 210, one of the angles is 210, one particular solution. 210, to convert this into radian, you multiply by this. 0 cancels by 0. By 3 it is 7, by 3 it is 6, 7 pi over 6. And the other particular solution is found on the fourth quadrant, So on the fourth quadrant, the reference is this 30 degree. So we are just seeking an angle from 0 to 2 pi. So the other angle will be this one. This angle, it is 330. Therefore, here this is 330. And we can convert this 330 into radian. You will have this is 11 pi over 6. So these two, x1 is equal to 7 pi over 6 and x2 is equal to 11 pi over 6 are particular solutions for sine x equals to negative 1 over 2 on the interval 0 to 2 pi. Therefore, the general solution will be simply it is 7 pi over 6 plus a multiple of 2 pi, comma 11 pi over 6 plus a multiple of 2 pi, it is 2n pi. So this will be the general solution for sine x is equals to negative 1 over 2. Now, let's see this one, cos x is equals to root 3 over 2. So for cos x equals to root 3 over 2, we need to find one particular solution. So cos x equals to root 3 over 2. this special angle cosine takes or this cos inverse of root 3 over 2, it is 30 degree. Cos 30 gives you root 3 over 2. So it is 30 degree. We have 30 degree here. So if x1 a particular solution, minus 30 will also a particular solution for this cosine function. Therefore, the general solution will be is power 6 plus 2n pi. 30 degree means when you convert into radian, it becomes power 6. One of the particular solution is power 6. The other will be it is x2 it is minus power 6. So the general solution will be it is power 6 plus 2n pi, comma, negative power 6 plus 2n pi. This will be the general solution, where n is an integer, by the way. N is an integer. Now, let's continue. Tan x is equals to radical 3. Tan is square root of 3 for this value. Tan inverse of root 3, it is pi over 3 or 60 degree. We have one particular solution. If you have one particular solution from negative power to power 2, the general solution will be that particular solution plus n pi, since tan is it's as period pi. Therefore, here the general solution for this will be this pi over 3 plus n pi, pi over 3 plus n pi. Now, let's see this one. Sine 6x equal to root 3 over 2. For this sine function, I need to find particular solution. Sine will be root 3 over 2 on 60 degree. So, it's positive. One of particular solution is 60 degree here. Thus, this one particular solution it is 60. When you convert it into radian, it is pi over 3. And the other particular solution, it is on second quadrant. This one 60 degree. Our angle this one 120 degree. So when you convert 120 into radian, you will have 2 pi over 3. So we have two particular solutions, pi over 3 and 2 pi over 3 for 6x1, not for x1 now in this case, because you are asked to find sine 6x. So the general solution for x1 will be simply pi over 3 plus 2n pi, since the period is 2 pi. So you can add this. And the other will be t6x2 is equal to 2 pi over 3 plus 2n pi. Because in this case we are not solving for x, simply we are calculating for 6x. So to find the value of x, you divide by 6. So, and you get this one. So x1 will be, the particular solution x1 will be, by dividing this by 6, you get pi over 18 plus 2n pi divided by 6 becomes this n pi over 3, and the other part, this one, when you divide by 6, you get that pi over 9 plus n pi over 3. So these two are the general solutions for this given equation. Therefore, the general solution will be, it is pi over 18 plus n pi, pi over 18 plus n pi, this one, general solution, and this is pi over 9 plus n pi over 3. This will be the general solution for this one. Okay, next we are asked to solve this one. 2 cos squared x plus 3 sin x equals to 0. So to solve this, we use trigonometric identity. Cos squared x, you know this, sin squared x plus cos squared x equals to 1. So cos squared x will be this, cos squared x will be this 1 minus sin squared x. Therefore, in place of cos squared x, I can put 1 minus sin squared x. We have 2 there, times in place of cos squared x, substitute 1 minus sin squared x plus 3 sin x equals to 0. And then this will be this 2 times 1, 2 minus 2 sin squared x plus 3 sin x equal to 0. And you get this one. So taking this to the other side, this becomes positive, this becomes minus, and this also minus. You'll have this one. And factorizing this, 2 sine x plus 1 times sine x minus 2 is equal to 0. So from this, the product of two numbers is 0, means either 2 sine x plus 1 is 0 or sine x minus 2 is 0. So this gives you sine x is equals to minus 1 over 2 and sine x equals to 2. Since sine x cannot be 2, this has no solution. This has no solution. But the particulars, we have solved this earlier, the particular solution for sine x equals to minus 1 over 2, it's found on third and fourth quadrant. So third quadrant angle is this 7 pi over 6, it is 230, that means this one is 330, we have already found earlier. Therefore, these are the particular solutions. The general solution, you can add a multiple of 2 pi on both, since sine is periodic of 2 pi. Therefore, the general solution will be this 7 pi over 6 plus 2n pi, comma 11 pi over 6 plus 2n pi. So this is it. To summarize what we have seen today, 1. The function f of x equals to a sine k into x plus b over k plus c. Its period is, it is 2 pi divided by the coefficient k, and its range is varies from negative of absolute value of amplitude plus c, comma absolute value of amplitude plus c. And if x1 is a particular solution on this range, then the general solution for the tangent function will be x1 plus a multiple of n pi. If x1 is a particular solution in the range negative pi up to pi, then minus x1 also a particular solution for cosine function, and the general solution will be this x1 plus 2n pi minus x1 plus 2n pi. For sine function, it will have two particular solutions, x1 and x2. So the general solution will be on 0 to pi. Its general solution will be this x1 plus 2n pi, comma x2 plus 2n pi. So this is all about today's lesson, and then I'll give you exercise. Please try to solve this and to draw the graph of this one, and read examples on page 371 to 376. In addition to that, please do exercise 9.5, which is found on page 376. So this is all about today's lesson. Until next lecture, goodbye.